Okay, hi. This video demonstrates my LabVIEW homework assignment number 2. The goal for this lab was to design a reusable SubVI that calculates either the mean or the square root, or the root mean square, the RMS of the three input signals. Then we use that SubVI inside a main VI to process those signals generated in real time using a while loop. On the first part A, the SubVI design. The SubVI I built has 4 inputs, x1, x2, x3, and mode. The mode is your control for the case structure. It uses case structure uh, controlled by the mode input. If a mode equals 0, the VI calculates the average of the 3 inputs using the formula. Let's go to the default. Uh, these 3 inputs, x1, x2, x3, all divided by 3. And then if 1 is entered, if the mode equals 1, the VI calculates the RMS value as the square root of x1, x2, x3 all squared, added together, divided by 3, and squared. I use the add, multiply, divide, square root blocks to implement these equations. No while loop was used inside the SubVI, which was a requirement. I also customized the SubVI icon so I could easily recognize it if I needed to reuse it. Right here in the yellow. Then part B for the main VI. Well, so yeah, this is my front panel, and this is the block diagram. Okay, going to, well, we can test it. 1, 2, 3, 2, 3. Hit run, displays 3. And if it is in mode 1, you can go 1, 2, 3 to the other one. Right, exit out of that one. Go to our main. There's the front panel, and here's the block diagram. In the main loop, this is our while loop. Everything happens inside the while loop, so the signals update continuously. First, I created a time variable using the loop iteration I. So t will equal I, the iteration counter, times 0.05. Using this time, I generated 3 signals, M1, M2, and then M3, which M1 is sine times pi t over 4. M2 is cosine pi t over 11, and then M3 is the product of M1 and M2. So M1 and M2 are sinusoidal, and M3 are their product. Next, I place 2 copies of the SubVI inside the loop and give them their modes. Both receive M1, M2, and M3 as inputs. The first SubVI has a mode of 0 and the output as Y, the average. The second SubVI has a mode of 1 and the outputs Z, the RMS value. This shows how a single SubVI can be reused for different calculations. And then charts and results. We hit play. You can see the sinusoid waveforms being formed. So on the front panel, I use 5 waveform charts to display M1, M2, M3, Y the mean, and Z the RMS. The chart backgrounds were changed to white as required. We can see M1, M2 are sinusoidal signals. M3 shows the product waveform. The mean signal Y appears smoother than the original signals, while RMS signal Z is always positive and generally has a higher magnitude, which matches the RMS theory. So the conclusion, this assignment demonstrates how, let me hit the stop button, see what happens. Get a drop. So this assignment demonstrates how design and reusable LabVIEW sub-VIs, how reusable they are, and apply in real-time signal processing applications. This program correctly generates signals, computes the mean and the RMS values, and displays the results dynamically. The behavior of the outputs matches expected mathematically and signal processing theory. And that concludes my demonstration of the uh, RMS and main VI and sub-VI creation. Thank you.